We're solving problem 8 from the 2024 AIME1. 8 circles of radius 34 can be placed tangent to BC of triangle ABC so that the circles are sequentially tangent to each other, with the first circle being tangent to AB and the last circle being tangent to AC as shown. Similarly, 2024 circles of radius 1 can be placed tangent to BC in the same manner. The in radius of triangle ABC can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. So the first thing we can do here, this is a really bad drawing of this triangle, but because there are two different cases, right? Case where there's 8 circles and all the circles are tangent to these points, and then there can be 22 circles that are tangent to sides AC and AB. So we want to find a relationship between those two cases. Let's just visualize this second case where the triangle is made up of 2024 radius 1 circles. So if we go like this, just gonna put a dotted line here, but it's gonna be tangent something like that. Now what we can do in this problem, if we have these 2 points, right, these 2 centers of the ends of the circles with radius 1, and then we draw a vertical like this, what this does is this splits BC into 3 parts. This long segment, and then these 2 segments. So this one, we're calling from the center of the last circle on the right to point B, have length lowercase b, and then the length from point C to the center of the circle of radius 1 on the upmost left is A. So we could find the sum of BC now. But how does A and B relate to this case right here, where the radius is 34 times bigger? If we do the same thing, we have the center of this circle and the center of this circle about. Well, this is going to have some correlation with this value of B, similarly to how this will have some correlation to the value of A. But these are similar triangles because these are 90 degrees and the angles are all the same. So therefore, they have to have a scale factor between those two. So because the radius of this circle is 34, all the lengths on these triangles will be 34 times that. So right here, oh wait, this is B, and this is C. Oops. But this length right here, this length will be 34 times A, and this length will be 34 times B. We therefore have 2 different ways to express the length of BC. So we have BC is equal to, if we take this case, right, starting from this circle to this circle, you have 22 circles. But then you're excluding the halves of the circles that were cut in half. So you do 2 times 2022, because the diameter of each circle is 2. And then you have to add these halves from the circles, from the cut in half circles, and then you have to add the value A and B. Similarly, with this case here, we can do 6 times 68, because that's the diameter of the circle in that case, and then you add 34 plus 34 plus 34A plus 34B. Now, once you solve the systems of equations, you get 1190 over 11 equals A plus B. Let R be the radius of the circle that this triangle is in. right? If r is the radius, then that means length BC, that means it must equal to, we can express it in r times a plus b. Therefore, if we solve by dividing both sides by a plus b, we get that r is equal to 4096 plus 1190 over 11 over 1190 over 11. Therefore, eventually giving us 192 over 5. So 192 plus 5 is 197, which is our answer for this problem.